Hey everyone, welcome. Today we are going to look at the factory pattern and how we can use it. In order to understand the factory pattern, let's look at a scenario in which we have an enemy script and a game controller, and the enemy script is responsible for creating different type of enemies and their life cycle, like attacking, dying and initializing them. So the current example you see on the screen does not use the factory pattern. Let's look at it. So here I have defined an enum. This enum holds the different enemy types. Then we have a mono behavior, which is a simple enemy class in which we have the enemy type enum. Then an initialize method which would set the enemy type, and an attack method with different debug statements for the different type of enemies, and a die method for the different type of enemies. Let's look at the game controller. So our game controller will spawn different enemies based on the level. So in the spawn enemies, we are basically creating different number of enemies based on the parameter we pass to this function. And this one would spawn the enemies in form of a wave, and this would spawn a single enemy at a specific position. And here, based on the level, we would spawn a specific type of enemy. Now let's say that we want to add a new enemy type. What we can do is, first of all, we'll need to add the enemy type here. Let's say we add goblin. Then we would need to add a new case like this, and this case would simply be enemy type dot goblin. Here let's change this to goblin. Let's say goblin subscribes to my channel. And here for the die, we also need to duplicate again and do the same thing over here. Let's see, goblin, and here we can say that goblin has subscribed. So this is how we can add a new type of enemies. And similarly, in the game controller, we would need to add a new if condition. So let's say that if let's just duplicate this one. If the level is greater than or equal to 10 and less than 20, enemy type dot goblin. So this is how we can add a new type of enemy. So we needed to make a change in many places, which can lead to errors, and some other disadvantages of this approach are there is no encapsulation of different types of enemies. The behavior of the different type of enemies is determined using the switch statements. There's direct instantiation in the game controller. There's less flexibility. Adding new enemy types requires modifying the enemy class and the game controller, which violates the open close principle. There is tight coupling, less separation of concerns. So we'll now use the factory pattern to address all of these issues. So let's implement the factory pattern in our current example. So how can we implement the factory pattern? It's really easy. So let's quickly do that. So let's remove all of this code and all of the code from the game controller. And let's go to Unity, and first of all we are going to create our enemy interface. This is going to be a public interface, and we don't need this mono behavior. And inside this interface we will have three functions. First one would be void public void spawn, which would take in a vector 3. Let's just call it position. Then a public void attack, and a public void die. So these are the basically the three functions inside our enemy interface. Now how can we create our enemies? So for the sake of simplicity, I will create the enemies inside this script, so it's easier for you to understand. But usually what we would do is we would create a separate script here. So for instance, if my enemy is a goblin, I'll create a new script called goblin and write the code in that. But for now I am going to say that public class goblin implements enemy, and all we need to do is implement the interface. So in the attack we would simply say debug.log goblin subscribed, and here we can say debug.log goblin subscribed and died. And in the spawn we would simply say, for the sake of simplicity, debug.log goblin spawned at the following position. So this is how we create our enemy. Let's create another type of enemy. Let's just duplicate this class, and this class will be called a dragon, and let's just change this goblin to dragon. Let's copy this, paste it. So this is how we can create different type of enemies. If we want another enemy, we will do the same thing for that as well. And on top of these functionalities, we can add other functionality as well, like a public void, let's say dragon dance function. So on top of this, we can add our own functionalities as well, but the interface provides common functionalities between the different enemies. So dragon danced. Now these are the concrete implementations of our enemies. Now we need to make an abstract implementation of the game controller, an abstract class called enemy spawner. Now this is going to be an abstract class. It's not going to be a mono behavior. inside this abstract enemy spawner, we'll have our factory method, which is a public abstract enemy, and let's call this create enemy. This is our factory method, and we'll also have a public void spawn or enemy spawner function. This would take in a vector3 position, and it would say enemy is equal to create enemy. We don't know what type of enemy it is, and simply enemy dot spawn and pass in the position. And let's debug dot log enemy spawned. So the benefit of this is that we don't need to know what type of enemy it is, and we shouldn't name it enemy spawner because our class name is enemy spawner. So let's just call it spawner. So we don't know what type of enemy we want. We don't have to do anything with that. We'll just tell it the spawner to create an enemy, and it will create that enemy for us. We need to create the concrete spawners. For the sake of simplicity, I'll create them here. So public, let's say that we have our enemy types, which is goblin. So we'll say goblin spawner, and this is a class, and this is going to be an enemy spawner. We need to implement this class and just implement the abstract class, and this will simply return new goblin. That's it. If we want to create a dragon, duplicate this, call it dragon spawner, and this will return a new dragon. Now let's put all of this together in the game controller. So in order to save time, I am going to paste my game controller here. So I have pasted my game controller, and inside this game controller, let me explain what we are doing. So there's an enemy spawner, which is this abstract class, and this abstract class, in the start function, we basically get the current level, and if the level is less than 5, then the enemy spawner would be a new dragon spawner, and this would basically spawn dragons. And the other functions are quite self-explanatory, but our main focus should be on this part, as we don't care about the type of enemy spawner. If we say spawn a dragon, it will spawn a dragon. And what are the benefits of this approach now? This provides extensibility. We can easily add new types, create new classes without altering existing code, meaning we won't violate the open close principle. And let's say that our dragon type enemy has an issue, then we would only look at the dragon type enemy class. We don't have to look at all of the switch statements and go through all of the code. Since the spawning logic is shared in the abstract creator, we avoid code duplication. Now there are some disadvantages to this as well, that we have a lot of classes, and this can lead to many subclasses being introduced in our code. This is the disadvantage of this pattern, but the advantages basically overweigh the disadvantages. So I hope you guys enjoyed this tutorial and I'll see you in the next one.